Hello, this video is over writing and then solving two-step inequalities and putting it on a number line. So let's look at this one. In our number routine, it says solve for m and graph on the number line. So do you see this variable right here, m? We need to isolate it. So how am I going to isolate this variable? Well, let's see. Let's get rid of this constant. So what is the inverse or the opposite operation of minus 7 plus 7? Are we done? No, you got to balance it on the other side. So this cancels out. M divided by 4 is less than or equal to, when you have 2 negatives and 7 positives, that's positive 5. So we're good so far. Again, if you are having trouble understanding why this is the less than or equal to, this side is less than this side. So what is, I need to isolate the variable again. What is the inverse of divide 4? Times 4. Times 4, this cancels out. M is less than or equal to 20. So let's plot it on the number line. 20, 22, 2 units less will be 18. Let me get my highlighter. It has to be less than 20. So these numbers are less than 20. But it has to be equal to 20. So if it's equal to 20, that means it includes 20. It is a closed dot. So let's check our work. Let's pick a number. I could pick 18, but 18 is not divisible by 4. It doesn't, so we need to pick something that's more easier to use. So let's do 0. What's wrong with 0? Because it is less than 20. 0 divided by 4 is 0. Minus 7 is negative 7. Is negative 7 less than negative 2? On the number line is farther, it's to the left of 0. So yeah, it's left of negative 2. Yeah. So we did our test points. Next, so here are some problem situations with equations and inequalities. Like number 1, Matilda needs at least $112 to buy a new dress. Where is she going, to prom or what? She's already saved $40, so she needs more money. She earns $9 an hour babysitting, right? And solve an inequality. So we know it's going to be inequality sign such as this, so it's not an equation, to determine how many hours she will need to babysit to buy the dress. So first of all, she starts with $40. Plus, she needs to work some. She works $9 times the number of hours. Do we know how many hours? No. What variable would you like to use? I'll use H. So 9 times H. So she starts with $40 plus $9 times the number of hours she works. It has to be, so 112 at least. That means 112 is the least amount of money she needs to buy the dress. Does that mean if 112 is the least, is $100 enough? No, you can't buy a dress because she needs at least 112. So she needs more than that. So it's more than, but she can have equal to. If she has 112, she's good. She can buy the dress. So now let's steps to solve it. I need to isolate the variable. So here's 9h. So I need to get rid of the constant. So I subtract 40 from both sides. 9h is greater or equal to, and 112 minus 40 is 2. 11 minus 4 is, I believe, 7. What's the inverse of multiply? Divide, divide, cancel, because this makes one whole. H is greater or equal to 72 divided by 9 is 8. That means she must work 8 hours or more. So here's 8, 9, 10, 7, 6, 5, 4, 3, 11, 12, 13. Let me get my highlighter. She has to work more than 8. So all these numbers are more than 8. But they could be 8. So I highlight that. Close dot. So it's closed dot because she can work 8 hours. So let's use a test value. I'll use 10. 40 plus 9 groups of 10. 40 plus 90 is 130. Is that greater or equal to 112? It is greater. Check. Mark. So let's try to do this in a word. How many hours will she need to babysit to buy the dress? She needs to work 8 or more hours, or more than or equal to 8 hours. Let's skip number 2. Let's go to number 3. Latrell has $12 to spend on postcard. He wants to buy one large postcard and some small ones. Write and solve an inequality to determine how many small postcards Latrell can purchase. So so it says inequality, so I know it's going to be greater than, less than, greater than, equal to, or less than, equal to. So he has $12 to spend. He wants to buy one large postcard and some small ones. Well, how many small ones does he buy? Oh, we're supposed to find that out. So it's inequality. So he wants to buy one large postcard that costs $2. Plus, he wants to buy some small one, $1.25. Do we know how many small ones did he buy? Nope. So let's use X. So he needs to buy a large one plus $1.25 times the small one. But he has only $12. That means can he spend more than that or less than that? He has to spend less than that. But could he spend $12? Yes. He has $12. He can spend all of it if he wants to, but he has to be spent less or equal to. So he has only $12. So let's solve this. So we use steps. So we need to get rid of this constant. So the inverse is subtract 2. Subtract 2, cancel. $1.25. X is less than or equal to 10. Ooh, what's the inverse of multiply? Divide divide by $1.25. So how many $1.25 go into 10? Many ways you can do this. You can keep on adding $1.25 until you figure out the answer. $1.25 plus $1.25 is $2.50. Plus $1.25 is $3.75. Plus $1.25 is $5. Plus $1.25 is $6.25. Plus $1.25 is $7.50. Plus $1.25 is $8.75. Plus $1.25 is $10. Let's count the number of $1.25 added. 1, 2, 3, 4, 5, 6, 7, 8. So it's 8. Not very efficient, if you can tell. So I'm going to erase that. So at least I have, you know what? I'm okay with that because, at least I have a standard of what it should be. It should be 8. Again, if you forgot how to multiply by decimal, it's been a while. What place value is this in? In the hundreds place. So we multiply this by 100. So 125 times 100 is 125. 10 times 100 is 1,000. So let's divide this. How many 125s go into 1,000? 8 times. So X is less than or equal to 8. That means he can buy 8 postcards, but it really got to be less than it. So X is less than or equal to 8. Let's do a number like 8, 9, 10, 7, 6. So so it has to be less than or equal to 8, but can it be 8? Yes, it can. So it has to be less than 8. So it's going to be all of these numbers that are less than 8. But it's about postcards. Can you buy a fraction of a postcard? No. So discrete or continuous. Continuous means it keep on continuing. Discrete is the better answer. So you can buy 7 postcards, 6 postcards, 5 postcards, 4 postcards, and 3 postcards. 2 postcards, 1 postcard, and just 0. So 0, 1, 2, 3, 4, 5, 6, 7, and 8. And to check your value, what if you buys 5? Let's do 0 postcard. 2 plus 0 is less than or equal to 12. Check mark. And our last one, number 4. Tyler needs at least $205, so he knows it inequality, for a new video game system. Spoiled kid. He's already saved $30. He earns $7 an hour at his job. Oh God, it's going to take him forever. How many hours will he need to buy? So he's already has saved $30. plus he works $7 times the number of hours, but he needs at least $205. That means to buy it, he needs $205. So it could be equal to that or more. It's good to have more money. So solve this. How can I get rid of, I need to isolate this variable. How can I get rid of this constant? I subtract 30 from both sides. Console. So 5 minus 0 is 5. 20 minus 3 is 275. 7h. So let's divide 7 on both sides because the inverse of multiplying is dividing. It cancels. Uh, stop, 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 stop. How embarrassing. I don't know if you caught this. 5 minus 0 is 5. 20 minus 3 is 17. So we divide 7 by both sides. So it's 175 divided by 7. Can 7 go into 17? 2 times. So 7 minus 4 is 3 and 5. So how many 7s go into 35? 5 times. So the hours has to be more or equal to 25. So hour is more or equal to 25. So this is 25, 26, 27, 24, 23 has to be equal to 25. Highlighter, but it can be more. It could be 30 hours. It could be 25 hours. So let's pick 30 hours. 30 plus 7 groups of 30, that's 210. That's 240. It's greater or equal than 205. Check. So that is the thing. So the rest of the class, you are going to be getting some cards, like such as this, and you're going to be matching it with the inequality. And then you're going to be solving it and making number lines. So this is writing and solving inequality.